absolute potential and potential difference, they are the two different things. We also know that is earth is arbitrarily taken at zero potential. Whenever a conductor is connected to earth, it also assumes the same potential that of earth, that is 0 volt. Over here, we have this 20 volt battery, and as usual we have some resistances 2, 3 and 5. We see that these are in series, and this point C is earth. Then generally the students, they say that the conventional current that is flows in this direction will come from here to here to here to here, and then this will enter into the earth. Please understand that it may be the cases in electrical circuits, it may not be the case. But one thing for sure is, whatsoever the point is earth, whatsoever the body is earth, that assumes 0 volt potential. There may be flow of current, there may not be flow of current. Like over here, if we say that the current goes like this and then it enters into earth, it means the lesser current will be coming from here and lesser current will be going back to the battery. Battery will not let it happen. Battery says, I have to maintain my electrical neutrality. Battery will never say that is today I am giving you some charges and you can return me back after some time. No, battery wants its charges instantly. So what's the charges, that is, be it electronic current over here, or if we talk about the conventional current, if the conventional current goes in this direction, that is charges they are moving in this direction, then certainly it wants it back instantly. So it is not possible that a current, that is, current is what? Current is basically a dq by dt, that is rate of flow of charges across any cross section. It is primarily the flow of charges only that constitutes current. So it is not possible that currents, while coming over here, it enters into earth and lesser current goes back into the battery. So this is not possible. So now over here, when we say that this C is earth, or from here to here the conductor is earth, it means the potential of C is equal to 0. That is, absolute potential is equal to 0. We have two things. We have absolute potential and we have the potential differences. So absolute potential of C is, now it is given as 0. So we can write over here, that is absolute potential of this is 0. Now we are asked, what are the absolute potentials of point B, A and D? C is obviously at a 0 potential. What we can do is, we can solve this question as usual we had been solving. Only thing is, now we have a reference potential, and taking this as reference potential, we can also find the absolute potential of the other points. Let's do it. So over here we see that is 2 ohm, 3 ohm and 5 ohm. They are in series. They are joined end to end. For a time being, forget this earthing. So 2, 3 and 5 ohm, 5 plus 3 plus 2, that makes 10 ohm. So battery says whatsoever current goes in this direction, the same current should be returned to the battery. So it means V is equal to IR. If we say V is equal to IR, V battery is 20 volt battery. I in the circuit, we have to find out I into R, equivalent resistance 2 plus 3 plus 5, that is 10 ohm. So I comes out to be 2 ampere. So it means the current that should be flowing in the circuit is going to 2 ampere. The 2 ampere will flow through this 2 ohm resistor, 2 ampere will flow through this 3 ohm resistor, and 2 ampere will flow through 5 ohm resistor, and 2 ampere will come back to the battery. Whatsoever charge is pushed into the circuit, the same charge is received by battery at the same instant. Now let's find the potential difference across AB. Conventional current is going from here to here in this direction, so it means VA is greater than VB. From here to here it is going, so it means VB is greater than VC, and VC is greater than VD. Potential of this is greater than potential of this, is greater than potential of this, is greater than potential of this, because the conventional current is going like this, and we know that the conventional current, positive charge is a flow from a higher electric potential to lower electric potential. The potential difference across this is V is equal to IR. We can use V is equal to IR, and V we have to find out V, that is VA minus VB is equal to I is 2 ampere, 2 into 2 is equal to 4 volt. This comes out of 4 volt. Across this, if we have to see, once again VB is greater than VC, so VB minus VC is what? Is V only. That is, when we say Ohm's law, V stands for what? V stands for potential difference. So VB minus VC is equal to I is 2 into 3, that is 6 volt. Across this CD, VC minus VD is equal to I 2 into 5, that is equal to 10 volt. If we add it, 10 plus 6 plus 4, that makes 20 volt only, obviously. That is what's the potential difference across this is 20 volt, this plus this plus this, that should make it as 20 volt only. Now these are the potential differences, 4 volt, 6 volt, 10 volt, they are the potential differences. Now we make use of this earthing. When we say this earthing has been done, this sign is used for earthing. So now if this is at 0 volt, this is given as 0 volt. Absolute potential of this is 0 volt because this has been earthed. If this is at 0 volt, this point, B point, is obviously at a higher potential. What is the difference between this and this point? It is 6 volt. It means the potential of B is 0 plus 6, so it is plus 6 volt. This is the absolute potential of point B. We know what is the potential difference between this and this. The potential difference is 6 volt. This is at 0. This is 6 volt higher to this, so this is at 6 volt. VA is 4 volt higher than what's the potential of B. So VA, absolute potential of A is 6. This is 6. 6 plus 4, that is equal to 10 volt. This is the absolute potential. This is not the potential difference. This is absolute potential. And when we come to D point, this is at 0 volt. This point is lower to it by a 10 volt value. So if this is at 0, so this has to be lower than this by 10 volt. So VC minus VD is 10 volt. We know VC is what? VC is at 0 volt. So 0 minus VD is equal to 10 volt, or VD is equal to minus 10 volt. So this is at minus 10 volt. Now instead of this being earth, suppose this is earth. If this point is earth, then obviously this is at 0. This is 10 volt higher to this. So this is going to be at plus 10 volt. This is 6 volt higher to this. So this is 10 plus 6. That is, it is going to be at plus 16 volt. A will be 4 volt higher to this. So 16 plus 4. So it is going to be at plus 20 volt. So if the network is earth over here, be it over here, be it over here, be it over here, be it over here, anywhere, let's say this, because this is a conducting wire from here to here to here to here, all the points they are same potential because this is a perfect conductor, all the points they are same potential. If we say this is earth, this is at 0 volt, then certainly the negative terminal is also at 0 volt and its potential, absolute potential will be plus 20 volt because the 20 volt is the potential difference between the two terminals of the battery. So if we say that this is earth, or this point is earth, or this point is earth, anything you can say this is earth, so this will be at 0 volt and this positive terminal will be at an absolute potential of 20 volt. If instead of this, let's say now B is earth. Now this is earth. So this goes off. Let's say we remove it for a time being. So if this is at 0 volt, so this is A is 4 volt higher to this. So it is 0 plus 4. This is at plus 4 volt absolute potential. What is the potential of this? C is 6 volt lower to point B because the conventional current is flowing in this direction. Conventional current flows, positive current flows from a higher electric potential to lower electric potential. So VB is greater than VC. VC is 6 volt lower to B. B is at 0 volt. So potential of C is 0 minus 6, that is minus 6 volt. This point D is still, because the conventional current is flowing from here to here, this point D is still 10 volt further lower than the absolute potential of C. So VD is equal to VC minus 10. What is VC? VC is already minus 6. So minus 6 minus 10. So VD is going to be minus 16 volt. So this way, whenever the circuit is earthed somewhere, you can find the absolute potentials of the various points.